Hey everyone, I hope you all are safe and doing good. So, in the previous lecture, we have discussed arrays. Now, in this video, we'll see more about arrays and we'll see for each loop, how to use for each loop with array. So, I have told you in previous lecture, like we can create arrays of all the primitive types, whether it's arrays of integer, arrays of character, arrays of double, arrays of float, arrays of boolean, and thus arrays of byte and short. For all the primitive types, we can create arrays. And we have seen that thing also. We have created some arrays. But I've told you one more thing that you can create arrays of object references as well. Right? Like if I write something like this, int this numbers. So this is what? Arrays of int type. If write here double and same syntax, this and here name of the arrays, then this is arrays of double type. Any number you can do like ARR. So ARR is array of double types. Like this, you can create arrays of all the primitive types. Now, you can create arrays of object references as well, not just of primitive types. So, like I told you, like arrays is like a collection of elements of same type. Fixed number of elements are there of same type. So, same, it can be a collection of object references as well. Array is itself an object. I've told you. Okay. And let's take one class. Any class you can take, student, employee, any. And you create object of that class. What is the syntax? Suppose you have a class something like this. This is the class. I'm having something, some attributes and some methods and all. But the name of the class is employee. How to create object of this class? You know the syntax very well. Just name of this class, then the object name. Suppose object name, any name you can take like obj. Any name you can take, ABC, XYZ, employees, anything. Is equal to new, and this is what basically default constructor employee. So this is how we can create object of this class or instance of this class, or more precisely if I say, then this obj is what? Object reference. So this object has been created of employee type in heap area, like this is like heap memory here, and in stack we have this obj which is referring to this object. Something like this is happening internally in memory, right? Now you can create this arrays of these object references. This is what? One object. If you want to create second object, then you will simply write maybe employee, or second object name is equal to new this. If you want to create four object, so four time you need to write down the same line. obj1, obj2, obj3, obj4, something like this. Or employee 1, employee 2, employee 3, employee 4. Rather than repeating this code, we can create array of object references. Arrays, because object references are of same type, so we can, like it's a collection of object references, and that is simply like array is a collection of elements of same data type, right? So now if you want to create five object references, so we can simply, syntax is same, almost same. So just the name, here we write simply what data type, then this syntax, sorry, this bracket, then the array name, suppose I take numbers, then at the same time you can instantiate this with new, and here again the data type, whatever is the data type, and here the size of the array. This is the syntax. Okay. Same here. Just the class type. The name of the type is here class. Class is what basically you can say it's a user defined data type as well. We have defined our own data type. So we can create any object of this type. So this is kind of data type, but user defined. These are built in data type. So same you have to, after employee, just these brackets. Then this is now an array. Obj is now not a single object. It's an array of object or array references of which type? Employee type is equal to new. Here, rather than constructor, you pass here whatever is the data type, that is employee, and size. So here you pass here something like this and size like 5. Simple. So now this obj is an an array of object references of employee type. 5 object references are there. So what is happening now behind the scene? in this heap now, memory has been allocated for 5 object references, not actual object. Obj is what? Object reference. So in memory, let me show you this thing here. Suppose this is heap area. So here we have like, these are 5 object references. So this is 0, 1, 2, 3, 4. Oh, let me just write down this here. 0, 1, 2, 3, 4. Index. And the starting index is at this stack, right? And the name is obj. So this is referring to here. So this is one object reference, another object reference, another object reference, object reference, object reference. So here it is containing reference of this array of object references. And I'm saying that this is itself an object reference because we have created array of object references. So actually, whenever you use this new, the memory would be allocated in heap, and that reference or that this would be stored in stack. There are two part of memory, two memory areas. Now itself will store reference, not actual object. This thing you need to take care. This thing you need to keep here in mind. Thing you need to understand. If an employee, I have two things. One is like maybe string, the name of the employee, and one is double and salary. Two things are there, right? So the actual object data would be stored somewhere else. It is still an object reference, this array of object references. So now each and individual object, it still contains what? Reference of something. So like reference of some data here. Now what is actually that data? This is actual object. So now you instantiate individual object. And how? So to access this, you write simply obj and same the subscript like index 0 is equal to memory. You have to create now actual object. So again new, and the type is what? Simply employee. Employee, and that's it. Now this will create a new object somewhere and in the heap, and the reference of this is stored in this obj 0 here, something like this. Now here actually this data is stored, name and salary. So memory has been allocated to store this data, name and salary. Here the actual object, the actual data has been stored. Reference of this is here and reference of this is here. Something like this is happening behind the scene. Okay, so if you want to access for the first object name, how you will access? First you have to go here. How you will go here at the first index of this array? The name is using this obj, you can access obj, and this is at 0th index, and dot. Now whatever here you want to access like name, and you can assign some value like Jenny. So in here in this memory, in this name variable is there, and there Jenny would be stored, something like this. And to access, if you want to access, then this also you need to, in system.out.println, you will write this thing only, right? So array of object means, object references means it stores multiple object of same type, means it stores object. Object basically references, not the actual object. More precisely if I say, then it is arrays of object references. Okay. Declaration same as you declare primitive arrays, but here you use class name. How you initialize? Create object of each array element. See, like this. Create object of each array element. So for first element, I am creating the object. Same for second, you will write like obj1 is equal to new employee, and this. This is how you create, allocate the memory, and then to initialize, to give some here the data, you can simply use the array initializer here only, or you can simply write something, this kind of thing also. Okay. So actually the behind the scene, what is happening, you got the concept now. Now let me show you this thing practically, how to create array of object references and all. So let's create a new Java class, and I'm naming it for each loop, because basically we will discuss here for each loop. Okay, so first let's discuss how to create arrays of object references. Now first you need to, suppose I have a class. So within the same package, see within this only I have many classes, right? So there can be a class employee. Suppose I create a class here, employee. Or you can create a class, or if you have any class here, like in care demo, if you have class care demo, so you can use that this class only. You can create object references for this class, array of object references for this class in this for each loop, because this is in same object. You can access this, it's public. Let's create a new class here, class employee, and there I'm simply using like string. Only two field I'm taking, emp name and like double salary. Two things only, that's it. I am nothing in this class. Or if you want, you can take one more, like void display, one method we can have, and this is going to display the whatever the information in this class, like the employee name and emp id. So in this display we are just printing the name and the employee salary. This is our class. We have one more class within the same program, within the same application. So the one class is public. In this class I'm having main, and within this main I want to create an object, so array of objects of this class. How to create object of this class? Simple method is employee name of the object. Suppose I'm taking obj is equal to new, and this is the constructor. And if you want to access these elements, then yeah, we can access just object name dot emp name, and we can assign some value, suppose Jenny, something like this, right? And like same obj dot, both the things we can access salary, any double salary we can take something like this, anything here, point something like this, right? And then if you want to print, then you can just call obj dot display, simple as that. Okay, now if you run this, let's see what output you will get. Or you will get let's select the current file, but here is one error in this program, because this is colon, here it should be semicolon. Let's run this. See, employee name is Jenny, salary is this. You got it? Now you want to create second employee, and you want to assign emp name and salary for second employee. So what is this one way? You just copy paste these things and create obj1 or any other object. So we have now two employees. So obj1, you can set the name and the salary, and you can change the name and all. If you want to create 5 objects, so same, you need to copy paste all these lines. But one is what? Rather than duplicating the same code again and again, you just create array. Okay, simple. So let's just delete this thing and now create array of object references. So the syntax is same, subscript here, sorry, this square bracket, and the name you can say obj also, but it's always recommended that you take name something like this. If the employee is a class, then employees, because it is employees in plural form, because it is like containing more than one object. So employees new, and here you have to give the size employee, and the size is suppose 3. Simple. Data type, it's of employee type. The class is because employee, it's a defined user defined data type. And then the size. Syntax is almost same as, like, if you create int array, exactly same you write int this bracket object array name new int size. Here rather than int, the type is employee. So that is the only difference. Now it's obviously this obj is not allowed here. Now one more thing I want to tell you. Now object references has been created, 3 object references. And these object references, the by default value of object references are null. So within these object references, we are having now null actually. So if you want to print, suppose if I want to print s out and simply employees, I want to print this employees. What do you think? What it will print? Let's run this and I'll show you. See, it's some weird kind of thing. This bracket show that it's array. L means like it, array of object references of employee type, and then some address kind of thing. Right? It's not exactly the memory address. It's like hash code kind of thing. Because in Java, they are working in an abstract way. User don't have the idea of memory addresses and all, so we don't know exactly. But it's kind of like some hash code related to that memory address, right? And this employee we have, this is in stack, so it is containing reference to whatever in heap that has created like three an array of three object references. Now, if you want to access at zeroth in the heap at first index what is there, so you will get null because by default you haven't initialized anything. So by default in object references there will be null. Like by default value for int is 0, for float is 0.0f, for character it's something else, for string it's null. So same for object references, it's null. So if you print a 0 or 1 or like at 1 index or 2 index, you will get here null only. See, at here only you will get null. And if you want to access here out of bound, that is 4. Let's run this and see what exception you are getting. Array out of index out of bound exception you are getting. Because 3 objects are there, so 0, 1, 2. Only till 2 indexes are there. Now actually you have to now declare, I mean you can say instantiate individual object. So how you will do, you cannot directly say like employees and at 0th index let's just access emp name and let's put here Jenny, something like this, and let's just print it's 0 dot name, sorry emp name, something like this. Let's run this and see null pointer exception. I have told you at first, so actually two areas are there. This is heap area and this is what, stack area, this thing we have seen. So whenever you call, when you will run the program, then the main method is being called and this is the main frame, stack frame. So this is stack frame for main. In stack memory, whenever you call any method, then one frame has been pushed in this stack related to for that method. So for main, we have one frame, and within this main, we are having what? Whatever the local object of this main, local variable of this main, those variable would be stored. So we have here first employee, something like this, or employees. This is the object, right? So this is containing reference of here 1, 2, 3 array. We have done like something like this, something like this we have done. So 3 objects are there and the reference is here. So these are object references. Here I am having null, here also null, here also null, because these are object reference. These are not containing actual address. These are object reference means it will store address of some other part. And you need to create this object now. You haven't created this object yet. That's why it is now null. And if you want to access this like employees, name of this is employees, it is referring to here index is 0, 1, 2, 0 dot emp name, and you want to assign some value here like Jenny. So see, it is null. So obviously it will give you null pointer exception. You cannot access something like this. First, just assign some address here. Then only you can access. So for this, you have to create the actual object for this index for the first object reference. Then it will refer here and then you can access something like this. Then this will be correct. Same for all the 3 you have to do, right? So let's do this thing. So you cannot assign field EMP name because employee 0 is null right now. Okay. So what you need to do to work this thing, first create like employees 0 is equal to create object for this. New name of the type is employee. It is same like we are creating object of any class. This is the constructor now, right? So now memory has been allocated, the actual object has been created, and the reference for that object is stored in employee 0 at 0th index. Now you can access. Now this is valid. Is equal to Jenny, and same you can like employees 0 second field is what? We have salary is equal to some kind of salary like we can have something like this. And if you want to print, so same we can do employees 0 and then dot and then salary. So it will give you two things, right? Both the things it will show something like this. Or if you don't want to, like we have a display method also, so directly you can call this display. Have to call employees 0 dot display. At this I want to call this method display. So let's run this and see employee name Jenny, employee salary is this. You got it now? So like this you just initialize all the three employees. 1 and 2 employees 1 and 2 are still null. Those object references are still null because we have created the object for 0th index only, for the first object only in the array for first object. So for first, for second, for third, same thing you need to do, right? You can just control C and control V. So let's create first, and here for first, for first, and for first. So let's change here something like name also and some salary also. So it will give you two employees and this. If you access the third employee, then it will give you null still, right? Or if you don't want to initialize something like this, rather than this, you can, one more way is you can just here create like this, and you can just simply write new employee like this. This is first like this. Rather than writing this line explicitly, we have just used array initializer to initialize each and every object of that array, object reference of that array. First for first, second and third we have created, right? Now if you run this, obviously it will not print anything because we have to set first to print. So we just set here name and salary and just display. You don't need to write this line. So it will print for the first employee Jenny and this. And if you simply print, if suppose I simply print here employees and at one what we have, I'm not going to access any name or salary. I'm just simply printing employees and at zeroth, sorry, at one index. What is there? So obviously here we should get some reference kind of thing. So this kind of thing you will get here. So don't worry about this thing. It is some reference of the actual object, right? Or it's like not actual address, like it's some kind of hash code kind of thing. Or what if I use this thing? Rather than writing this, I simply delete this and use array initializer. So this is the third way, the most simplest one. Let's run this. And it will also print same like Jenny, and this is the salary for first employee. So the three ways we can apply with this. In the previous lecture also for primitive arrays, we have discussed three ways to create, to declare and initialize that array. All the three ways I have discussed here. Okay. This is what just array initializer we are using. No, explicitly you need to write down here new employees and all. So you can try this out. This is how we can create arrays of object references. So you can create arrays of string also, because string is also an object. Here also if you want to create like string and this kind of thing, and names is equal to just assign some name Jenny, comma, file, Any name you can assign, maybe like Rahul, something like this. So this is also names is also an arrays of object references. Okay, string is not primitive type. String is also an like a special class in Java. So we are creating like an object reference. So it's like arrays of object references. Okay. Here also if you need to print like SOUT and if you need to print names at 0. So it will give you simply Jenny. See, Jenny, and this is for the second one. Here no need to write down explicitly like something like this, new employee and this, because it is special thing. It's implicitly in string. Either you can write down this thing also, or if you simply write down string this and just print access this something like this. Okay, in string it is allowed. Now let's discuss what for each loop. So we have discussed this thing, how to declare, how to initialize arrays of object reference, how to create an object array. This thing also I have shown you practically, right? And this is what one example. Let's this is a class student, then how to create the array of the students and then how to initialize each object. This thing we have seen with one class, that is what? Employee class. Now initializing and printing, we have seen this thing also, how to access, how to initialize, how to print. This thing also we have discussed practically. Now next is for each loop. One loop we have discussed, that is the traditional for loop. And if you access or traverse the array elements, this thing we have seen in previous video, how to use for loop. Just start from 0, run the loop till the length of the array I plus plus, and then just print using index. Name of the array in those square brackets, just use the index or that counter variable you take like I. That's it. But there is an enhanced loop also, that is for each loop, and it is much more simpler than the traditional for loop. And this is basically used to traverse arrays or those collections like array list or some other collections. But right now we are discussing arrays, so we will discuss for each loop in the context of arrays only, right? What is the syntax of this for each loop? If there is some array, suppose I have this array numbers, and here I am having some numbers 1, 2, 3, 4, 5, like this. If you want to traverse this or print all the numbers, either you can use traditional for loop, but here we will use that enhanced for loop, that is for each loop. The what is the syntax? See, simply the for keyword is same. Then we write the data type. We take a variable. So the data type here must be same of this collection. Here simply we have array. So same of this. The data type is int. So you have to take the same data type, that is int only. Here you will take the variable name. Any name you can take. XYZ, ABC, anything. So simply suppose I'm taking here num. Then colon, it's not semicolon, it's colon. And after that, just name of that collection or the array you want to traverse or you want to print or you want to access. Here I want to access array. The name of the array is numbers. So here simply write numbers. That's it. And here in simply system.out.println, we write only this variable. No index kind of thing, no square bracket, nothing else. You simply print num and it will give you 1, 2, 3, 4, 5. Now see, in traditional for you have to initialize that counter variable you take, then put some condition, termination condition, then update I plus plus or I minus minus. And then in here also you write the name of the array and in subscript this variable you take, whatever variable you take, that's I or num or anything. Here you can take I also. It's not like that you have to write down num, you cannot take I. No. It's not like that for that the I has a copyright, like for the traditional for has a copyright of using this I variable. No, this I variable you can use with for each loop also, with enhanced loop also, right? But here this I is not a control variable. It's not contain the, it's not have the index of that array. This variable, whether it's I or num, suppose here I'm taking num. So this variable represents the elements of the array itself. Now in numbers you are having these elements. So at first, this 1 would be assigned to this num. So in num at first we have 1. So that's why we simply printing num and it will give you 1 only. Then in next iteration, this 2. This 2 would be assigned to this num. Now num becomes 2 and now next time 2 would be printed. And till end of this array it would be repeated and till 5 we will get automatically. This is implicit. The condition is implicitly written here. No need to write explicitly. Modification is also done implicitly. No need to write that thing. So they have, the makers of Java, made this loop a much more simpler and cleaner. See, it's much more simple to write and clean to understand, easy to understand. It's more readable, right? Because that traditional for loop was being used by the developers, most frequently used loop. That's why they did this thing, that let's modify it a little bit and let's make it easy to use, more readable. That's why they enhanced this thing. We also generally use for loop rather than while and do while loop. Most of the cases we love loop, for loop. That's why they enhanced this loop a little bit, right? Now here, this variable or is not containing any index of this array 0 1 2 3 4. No. So if you need to access the index, or if you need to modify the elements of the array based on the position or the index, in that case you cannot use this loop, because this will not store index. This variable will store the element itself. In that case you have to go for traditional loop only. But if you want to print simply the array, traverse the array, don't want to modify anything, then simply you can use for each loop. And further, for most of the programs we will use for each loop only for arrays, because it's simple to use, right? So I hope you got the syntax of using for each loop and the advantages also why we use for each loop. So let's see a program on this for each loop. So let's just comment out everything here, and in main we simply first create a array of type int. Suppose I have numbers, array of numbers, and simply here I'm taking some values in this array. Any value you can take. If you want to print all these things, one way is we simply use traditional for loop, and that thing you know very well. Let's take a counter variable and this should run from 0 to numbers dot length till the length of the array and a plus plus. And we simply in system.out.println we can access like numbers, and in subscript just the index, that is in I variable, right? So rather than ln we simply print here with a space in the same line. So it is traditional for loop to access, to traverse the array. Okay, array out of bound exception. Why array of out of bound exception? It should be less than only, not less than equal to, because length is 1 2 3 4 5. So it will give you 5, but index is from 0 to 4. So it should be less than 5, not less than equal to 5. This thing you need to take care. Array always start from 0. So you'll get this one. Now rather than this loop, I want to print this array with for each loop. So for the data type, so the return type is exactly same as the data type of this array or the collection, whatever you use here, array list or array or whatever else. Here int, so int, then variable name, let's suppose I only, same name, then colon, then name of that array or that collection. And within this, we simply write here I. Simple. Here I is not having any address. So let's just comment out the traditional for, and let's just print the array with this. So you will get the same output, right? But if you want to print this in the single line, say, yeah, you can just use print here and with a space, that it will print in a single line all the things. See. So as you can see, this is much more cleaner and easy to read and simpler to write rather than this thing. This condition, this plus plus and kind of thing is implicitly added here in this for each loop. You don't need to write down explicitly. Okay. But there is no index kind of thing. This I here is working as an index. See, in index, we are writing something like this. But Here this I represents the actual elements of the array, not the index. So we are simply printing I. So if you want to access the index and you want to modify the array element using the index, then we cannot use for each loop. For that you have to use this loop only, traditional for loop, because there is no index here. So it simplifies, like you can say, the looping by reducing the need of for an explicit index variable. And suppose here the array is of like double, something like this. Now it will give you error. See, provided is int and required type is double. I told you that this type should be same as the type of this collection or the array, whatever you take here. So here you must take double, because from numbers, at first the first element would be stored, would be assigned to this I. So definitely if this is in double, this should be double. But if this is int, in that case, see, it will not give any error. So it's not like that type should be exactly matching. It should be like more precisely, if I say, then it should be compatible. Means this is 34 is now int. So that's at first this I becomes 34 when this value would be assigned. When this loop is going to be executed, this I would be 34. I is double. So it's okay. I is having larger data type. 34 is smaller. So it will be automatically promoted to double, and 34.0 would be stored in this. And it will print 34.0. You run this and see. See, all are converted to double and it will give you this output. So do not think that it should be exactly same. Means whenever I say like exactly it should be same, it means it should be compatible. Type promotion is allowed, but the type like demotion kind of thing is not allowed. If here you take double and here you take int, that is not allowed, because double cannot be converted automatically by to int. Larger to int means, sorry, larger to small means there should be a lossy conversion. We can lost something. Like if we have two glasses, one is full of water, and like one is like that big glass and full of water, and another one is small one. So if someone say just convert, just you can say transfer the water in that small glass, so definitely some water would be, you know, lost, like spill on the floor. So there would be loss of some data. That's why automatically it's not to be done. Yeah, you can typecast that thing, that will be allowed, right? So here explicitly we cannot put any condition kind of thing that we have done in pattern printing question, like I less than something like this. So this kind of thing is not allowed here. So this loop is simply mainly for traversing arrays and collections. Traversing means just printing from here to here, from starting to end. This is kind of traversing. So mainly to traverse arrays and collections, simply for that, this for each loop. It does not give you some access to that index of this array. So we cannot use it when you want to modify the array based on the index or based on the position. Okay. Now let's have some exercises on this for each loop. So first exercise is you have to print. Let me just write down this thing. First, let's just open a project that is coding exercises, and there we just print a new Java class. So here we have for each loop exercises, this thing. Let me write down the first coding statement. So these are three exercises. So first is this: sum of all the elements of an integer array using for each loop. Then count how many times a specific character appears in a given character array. There is a character array having some characters, and you will be given one character. Suppose in array we are having A, B, then A, then C. Then I have just given you a character that is A. You just have to count how many times A is there and just print that count. Third is you have to print all the even number from an int array. These are very simple one. But using for loop, you have to do these programs. So pause the video now and try this out. So I hope you have done the first one. Let's try out this. So let's just first, obviously in main function, we write some everything. So this is our first exercise. Right? Let's take an int array. Any array you can take. Numbers. This is the array we have. So what we do, have to print sum of all the elements. First access this, then access this and do 1 plus 2. That is 3. Now access the third element and do whatever is sum in of those previous two, just add 3 there. Then add 4, then 0, then 8, then 10 and something like this. So let's take a variable like sum is equal to 0 at first. Right? And traverse the array because we have to traverse. We need each and every element. So just traversing is required. So we use for each loop. So int, let's take a variable num and the array name is numbers. Now what you need to do, simple. Sum plus equal to whatever the number is there. That's it. And after that, simply print sum. Simple as that. It's not that much tough. Let's just select the current file here and run this. So what would be the sum here? It's 28. So you can just use some calculator and do it is 28 only. So I guess that was not that much. This is not that much tough. Let's try out the second one. If you haven't tried out, now you can pause the video and try this second exercise. Okay, you are given a character array. Let's take a character array. So this kind of thing we have. Like this is a character array we are having. Array name is letters and this is how you can initialize this. The simplest form I'm using. There are three ways to initialize the array. You can take anything, any way you can use. But this is the simplest one. That's why I'm taking using array initializer. Now, target, let's suppose the target or the letter or any variable name you can take here. The target is you have to find out how many times A is there in this character array. So you traverse this. If this is A, just you do count plus plus. Then check this next one. If this is A, just do count plus plus. Otherwise, access the next element, check the next element, check the next element and the next element till the end of the array. So it means you have to traverse the array from starting to end. And for that we have a loop. We know that is very simple. So first let's take count is equal to 0. And for traversing we have a loop for, but the data type should be like char and let's take ch variable name and letters. And we have to put some condition. If the ch is equal to target, whatever the letter you have given. If this is the case, if both are equal, then only we will do count plus plus. That's it. And after this for loop, let's just print whatever the count is. That's very simple. So it should print 1, 2 because count of A is 2 in this array. So see, you get here 2. If you change this target, if the target is suppose B, let's run this and B is only single time, so it will print 1. Very simple. It's not that much tough. Or rather than char, suppose I take here int. See, it is not giving you any error. Okay. Now let's see what output you will get here. It will give you 1 only because int is larger. And we know, I told you that characters are basically internally stored as unsigned integer. So int also you can take. It's not at all a big deal. Okay. But the data type should be compatible. So I would recommend better to take the same data type just to avoid the confusion. Now let's try out the third one. I hope you have done this program. Print all the even number from an int array. So let's take an array only. integer array we have to take. So let's just copy paste this thing. And from here you have to print all the even number. So how to print? You have to traverse the array from starting to end and check if the number is even. Just print that. Otherwise, skip that. Have to check this is even or not. It's very simple. It's divisible by 2, then even, otherwise not. So let's just write here int num and then numbers. Let's put if condition, if whatever the num modulo 2 equal to 0. Sorry, it's mod 2 equal to 0. In that case, we are going to print here whatever the num is. Simple as that. Otherwise, we don't print anything. So it will give you 2, 4, and 0, 8, and 10. If you just remove this 0, because obviously 0 mod 2 is equal to 0 only. So if you change this to 20, let's run this. Okay, we are getting it 2, 4, 28, and 10. And this thing we want. So I hope you have done all these things. These are not that much tough. So we are done with this for each loop introduction. How to use, what are the advantages, the syntax, and the limitations. This is one example here. For each versus traditional loop. This is just the comparison. The syntax is much more simpler for each loop than this. Traditional for index access not possible in for each loop. Yes, it's there. Modification, it's limited in for each loop. We cannot modify because we don't have like access to that index. So directly using the index, we cannot modify the array element. Reverse iteration is not possible in for each. In traditional for it's possible. Reverse means like this is an array. So using traditional for, we can traverse the array from reverse also. Just set the starting of that I till the length of the array. Like this is the array. 1, 2, 3, 4. So I want to reverse it from here. I want to print 4, 3, 2, 1. So for each loop, in for each loop, it's not possible because that will definitely go from here to here only. But with traditional for, we can do this thing. You can pause the video and try this out. How to print this thing with traditional for. I hope you have done this. It's very simple. Just set the variable like int I is equal to whatever the numbers, the array, suppose numbers dot length minus 1, and then I greater than equal to 0 and I plus plus. Simple. So length is 4. So it would be like 3. So at 3, whatever you have, 3, 2, 1, 0. So this would be traversed in reverse order. So with the traditional 4, it's possible. So some benefits like it's more readable, it's more clean code, safety is there because index out of bound errors are less in this case, more optimized for arrays and collections like array list and list, something like this. It's best to use to traverse arrays and collections. And it works with arrays and more iterable objects. Iterable means array is an object and that is iterable object. Iterable. We can iterate through the array. We can iterate through the list, array list. So these are iterable objects. Okay. Now there are some exercises for you. You have to create string array with 5 color and just print those 5 colors. Or one more challenge is what you can print index for each color. So you just try out this exercise with both traditional for and for each loop. Next is you have to create array of 3 book objects. Means it's like this book is a class. So you have to create array of object references of that class. We have seen that thing also. And you just print, use for each loop to print book titles. In that class, we have titles of that book and you have to access those titles. So it's like example of array of object references. Okay. Now that's about this. But whatever exercises we have done, 3 exercise and 2 are here. So just try out these exercises with traditional for loop as well as for each loop. You get a better understanding between, the difference between the traditional for and for each loop. Right. So that's it about this lecture. In the next lecture, probably we'll see 2D arrays, or first we'll see some exercises on arrays only to get a better understanding on arrays. Okay, some lead code problems as well. So now I'll see you in the next lecture. Till then, bye bye. Take care.